Last meeting, we started how to break forces in 3D, and we learned two cases. Just a reminder, we have x-axis, we have y-axis, we have z-axis, and there is a force F with three angles. The first one called alpha between the force and x-axis. Second one called beta between the force and y-axis. The third one called gamma between the force and z-axis. We learned three things in this case. The first one, we have a relationship between these three angles. Cosine square alpha plus cosine square beta plus cosine square gamma equal 1. That means if you have two angles and the third one is missed, you can figure out the third angle. The second thing we need to learn, this force as a vector equal this force as a value cosine alpha, you can get the x component. This force cosine beta, you can get the y component. Plus f cosine gamma k, you can get the z component. So we have three components right now in x direction, in y direction, and z direction. We learned also if this force is given as three components, fx, I, fy, j, fz, k. For example, for any reason, this force as a vector is given. The three components are given. So I can figure out the three angles of this force. How? We need first to figure out the value of this force equal square root of this component square plus this component square plus this component square. We will get only one value for this force as a scalar value. Then cosine alpha will be x component divide f. Cosine beta equal y component divide f. Cosine gamma equal z component divide f. I assumed the force is given as a vector. If the force is given as a vector, I can go back to figure out the value of this force and each angle with the x-axis, y-axis, and z-axis. We covered all of this stuff last time. We covered also last time, if you have a force, here is x, here is y, here is z. We have a force F passing through 2 points. First point, second point. And I can figure out coordinates of each point, x, y, and z for point number 1, x, y, and z for point number 2. If you can, then this force as a vector equal this force as a value time. Time what? X coordinate of the second point minus x coordinate of the first point in x. Y coordinate of the second point minus y coordinate of the first point j. Z coordinate of the second point minus z coordinate of the first point k. Divide this value square plus this value square plus this value square, all of them under square root. So finally, I can convert this force as a vector equals something I plus something J plus something K. That means this value will be the component in x-axis, component in y-axis, and the component in z-axis. Any questions so far? Any questions so far? Okay, all of this stuff we covered last time. The new topic today, we have something different. We have angles, but these angles are not between the force and x, or between the force and y, or between the force and z. No, it's something different. We have a line here, this line called projection line. Projection line is a line in xy plane. Guys, can you see? We have here, this is y-axis and this is x-axis. So this plane can be called xy plane. So this line, which called projection line, is a line in xy plane. And you have angle alpha between the force and this line, which called projection line. Then we have angle beta between this line, which called projection line, and x-axis. Okay? Okay? The same thing here. We have line here. This line called projection line. And this line is in xy plane. This time we have angle alpha between the force and the z axis, and then we have angle between the projection line and the x-axis. So we have something different. We have something called projection line in xy plane. So we need to start from this point. But before starting, I would like to remind you for something. We have z-axis and we have projection line. This line is projection line. And if you have a force like this, and your angle like this, and I would like to break this force between this line and this line, anybody can tell me which one will be cosine, which one will be sine? Between the projection line and z. Z and the projection line are perpendicular in 3D. And we have a force in between. And we have angle is given, but this angle between the force and the projection line. So right now I would like to break this force between these two lines. So which one is cosine, which one is sine? Do you remember first week in this course? I told you cosine component is the adjacent to the given angle. So your given angle is here. So this component will be f cosine alpha. The faraway component will be f sine alpha. Anybody has any question for this point? Thank you, John. Yes. Anybody has any question? That means if your z axis and the projection line like this, and the given force like this, and the given angle is here, sometimes So which one will be sine, which one will be cosine? Okay, the Z will be F cosine, because we know the component adjacent to the given angle is cosine. Far away will be sine. Please be careful about this point. Be careful about this point. Any more question? This one is very important. Okay. Right now, I have projection, which is in this case F cosine alpha, and this line called projection line. And this projection line is in X and Y plane. And we have another angle here between the projection line and the x-axis called beta, for example. The situation right now, I would like to break this projection line between y-axis and the x-axis. Anybody can tell me which one will be cosine and which will be sine beta? Beta is given. So the adjacent component for beta will be cosine beta. So we have this force, how much? F cosine alpha. This is the force. Cosine beta. And we have a force, F cosine alpha. Sine beta. So finally, this force is broken to three components, one in X, one in Y, and one in Z. So your steps for this case is very simple, but be organized a little bit. First, break the force between Z-axis and projection line. This is the first step. Which one will be sine, which one will be cosine? I don't know. It's based on how this angle is given. But I know the component adjacent to the given angle is cosine, and the component far away from the given angle is sine. So first step, we need to break the given force between projection line and Z-axis. Then we have a value for projection line. Go ahead and break this value to X-axis and Y-axis using another given angle between the projection and one of them, X or Y. So second step, break the projection line between X and Y axis. Just only two steps. Only two steps. Before starting an example, any question? Any question for this point? Okay. Okay. So let me explain it one more time here. Please don't put it as a stamp. No, it's not a stamp. You have to figure it out. First step, let me start with this case. First step, we have a force. We need to break this force between this projection line and this z-axis. Which one will be cosine? Which will be sine? The given angle, this one, I don't know. I don't care about the name. Alpha, beta, gamma, I don't know. We have angle given between the force and the projection. So this component will be F cosine. And this component will be F sine, far away from the given angle. Second step, we need to break the projection line between X and Y. We have another angle given, which is beta, between the projection and x-axis. So this angle is given. So the component adjacent to this angle will be cosine beta. Which one will be cosine? I'm sorry, which will be multiplied by cosine? The value here. What is the value here? Is F cosine alpha. And this component will be this value, which is F cosine alpha. This is the value. Time sine this angle, because this component is far away from the given angle, sine beta. So finally, X component for this force is F cosine alpha cosine beta. Y component of this force is F cosine alpha sine beta. Z component of this force is F sine alpha. Sometimes we have different arrangement like this, but the same steps. First step, we need to break this force between the projection line and the axis. Tell me, please, which angle is given? This angle is given. So which component will be cosine? The adjacent component will be cosine. So we have here F cosine. And this projection line will be F sine. Second step, we need to break this projection line between x-axis and y-axis using another angle, which is beta. Sometimes is beta here, sometimes here. I don't care. So please go ahead and see which angle is given. The adjacent component will be cosine. So the adjacent to this angle beta is x. So this one will be cosine beta. So we have F sine alpha cosine beta. This value F sine alpha, which is the value of the projection line, will be multiplied by sine beta. So finally, X component for this force will be F sine alpha cosine beta. The Y component will be F sine alpha sine beta. The Z component will be F cosine alpha. So please don't say we have a rule cosine or cosine sine. No, because sometimes the arrangement is different between a case and another case. So please follow my rules. Which one is cosine? The adjacent component. Which one is sine? The far away component. Let me do this example here. We have a force, call it F, not A, F. How much? 30 kilonewton. How much? 30 kilonewton. So F equal 30. We have two angles. The first angle between the force and Z. The second angle between a line here. Do you remember this line? Yes, projection line. And the x-axis, which is 40. We need to figure out the three components of this force in X and Y and Z. Do you remember the first step? Yes. We need to break this force between the projection line and z-axis. Which one will be sine? Which one will be cosine? Based on the given. Which angle is given? 30 between the force and the z. So this component will be 30 cosine 30. 30 is the value of the force. The second 30 is the value of the angle. And the projection line component will be 30, the force, sine the given angle 30. Second step, we need to break the projection line to two components, one in X and one in Y, with a new angle between the projection line and the X-axis. For example, it's 40. Which one will be cosine? Which will be sine? This component in X will be cosine 40. Which value will be multiplied by cosine 40? The projection line. How much? 30 sine 30. This is the value. And Y component will be 30 sine 30, the projection line, time sine 40. So finally, X component of this force equal 30 sine 30 cosine 40. How much? Fy equal 30 sine 30 sine 40. How much? Z component equal 30 cosine 30. How much? Guys, any questions so far? This part is the hardest part in 3D, actually. This one, you need to think a little bit. You need to pay attention to what is the given, to be familiar. Which one will be sine, which one will be cosine, which component will be sine, cosine, which one will be sine, sine. Okay? But until this moment, any question? Guys, any question? Okay. One more example. Let me do one more example. Let's do this one. Example number 5. Determine the coordinate angle for F2 and then express each force acting on the bracket as a Cartesian vector. We need to figure out what are the components of each force. We have two forces, F1 equal 450 and F2 equal 600 Newton. So let's start with F1. This force, we have two angles given. Do you think we have alpha, beta, gamma? Or we are in the third case that we cover today? It's very simple. Do you have projection line? Do you have the given angles are between projection line and the X or Y axis? I think yes. We have a line here. This line is not X. This line is not Y. This line is not Z. So this line can be called projection line. First step, we need to break the given force F1 between Z and projection line. Go ahead and do this. So we have Z component and we have projection line component. Second question, which component will be cosine and which component will be sine 45 degree? Because your angle between the force and projection line is 45 degree. So which component will be cosine, which component will be sine? I think the component adjacent to 45 degree will be cosine. So we have here 450, the force, cosine 45. This is the projection line component. And your Z will be 450 sine 45 degree. Second step, we need to break the projection line component to another component, one between y and the other one will be in x, probably in x positive or in x negative. This is the positive direction and this is the negative direction of x, whatever. Just to make it clear, here is the x-axis, here is the y-axis, here is the projection line, which is 450 cosine 45 degree. And the other given angle, which is 30, between the projection line and y-axis. So we need to break this projection line between x-axis and y-axis. I believe that this force will come in this direction like this, 450 cosine 45 degree, which is the value, cosine 30, and will come in this direction, how much? 450 cosine 45 degree, which is the value, sine 30. So final conclusion, f1x will be negative 450 cosine 45 sine 30. Why negative? You are lucky. The projection line can be broken in this direction, which is negative direction of x, and this direction, which is positive direction in y. So your final answer here will be 450 times cosine 45 times sine 30. Your final answer equal negative 159 Newton. F1y, y component, equal positive 450 cosine 45 degree cosine 30 degree. So 450 times cosine 45 times cosine 30, your final answer will be 349. The component of this force will be the first value here, 450 sine 45 degree, will positive. So we have 450 times sine 45 degree will be 318.2. I am done with only F1. I am done with the three components for F1. Remember, we have only two steps for this case of 3D force. First step, go ahead and break this force between the projection line and the z-axis. Second step, break the value for the projection line between x and y. Be careful about which direction you are in. Sometimes you are in positive, sometimes you are in negative. So be careful. Second one, we have F2. We have F2. And we have two angles. Okay, be careful. Are you in case 1 or case 3? The first angle, 45, between the force itself and the x-axis. The second angle, which is 60, between the force itself and y-axis. I think we are in case number 1. This angle is alpha. This angle is beta. So angle gamma is missed. Can you figure out what is the value of angle gamma? I think I can. How? We have an equation saying cosine square alpha plus cosine, I'm talking about F2 right now. Cosine square alpha plus cosine square gamma, I'm sorry, beta plus cosine square gamma equal 1. So cosine square, how much? 45, 60. 45 plus cosine square 60 plus cosine square gamma equal 1. What is the value of angle gamma? I can use my calculator. Cosine square 45 degree plus cosine square 60 minus 1 square root shift cosine. This angle is given 60 degree. 60 degree between the z-axis and this force. So I can figure out this force F2 will be F cosine alpha I plus F cosine beta J plus F cosine gamma K. So I can figure out the three components with the value of 60. But I have question, just a moment. Actually, I will use the angle 120, not 60. Anybody can tell me why? If you can tell me why, actually gamma can be 60 and it can be 120. Anybody can tell me why? This value will be 1/4. This one will be 1/2. So if you add this one plus this one to the other side, just a moment. Cosine 45 square, yes, and this one cosine 60 square, yes. So if you add this value plus this value to the other side, I will find cosine square gamma equal 1/4. So cosine gamma only will be 1/2. So if you apply inverse cosine, you can get gamma. Can you do it with your calculator? But we should have two angles. One is 60 and one is 120, and I have to choose between both of them. If you answer this question, I will give you 3 points in your next exam. I think I have 4 students last time, but why I have here 2 angles? If you are using your calculator, inverse cosine for 0.5, which is 1/2, I will get 60. So why you are talking about 120? Okay, June, you are right, but mathematically, I'm asking mathematically. This equation, I'm missing something here. I am missing something here. How can I get 120? We have two answers. Cosine gamma or cosine square gamma equal 1/4 can give you 2 answers for gamma. I will choose one of them and I will let you know which one is the correct one. But how can I get the 2 values? This is my question. If you are using your calculator, you will get 60, I believe. Bishal, you have 3 more points in the coming exam. Bishal Karki. I think you have, yeah. بيشنكاركي. 3 more. Today is September 11. Yes. Thank you. Guys, mathematically, if you have a number square equal 4, and you would like to get this value, so you have to make square root. A square root of 4 must be positive or minus 2. So right now we have cosine square gamma equal quarter. So cosine gamma will be positive or negative 1/2. If you are using a positive 1/2, you can get 60. If you are using a negative 1/2, you can get 120. So we have two angles for gamma, 60 and 120. Which one you have to think? Do you think the angle between positive z-axis and this force, I think this angle is obtuse angle. So this angle will be 120. It's obtuse angle. It's too much to be 60, so it will be 160. But the reason, the mathematical reason behind you have two values for this angle, your square must be positive or negative. Okay? Anyway, just you get your angle and choose the correct one, you can get the 3 component for F2. Horizontal and I'm sorry, X component, Y component, and Z component. Okay. Okay. One more example. Let's do it here. Example number 8. We have a hook subjected to two forces, F1 and F2. We are looking to determine the magnitude and the coordinate angles for the resultant force. Wow, resultant? Yeah, resultant is nothing. Once you did your component, you are done. Let's start with F1. F1. What do you think about F1? Which case? Is it case alpha, beta, gamma? Or case we have projection line? What do you think? I think for F1 we have angle 60 between what? And we have angle 45 between what? This line is projection line. This line is not collinear with x-axis. Be careful. Okay, so we are in the third case. First step, we need to break this force between projection line and the component. So I believe I have here a component in the projection line equal 300 cosine 60. And we have the component 300 sine 60. Then between the horizontal the projection line and y, we have 300 cosine 60 times cosine 45. And we have here in x negative will be 300 cosine 60, which is the value, sine 45. So finally, for F1, x will be negative 300 cosine 60 sine 45. I can figure out the value. F2, I'm sorry, F1, y will be positive 300 cosine 60 cosine 45. I can figure out the value. F1z will be positive 300 sine 60. Here is my calculator. I can figure out 300 times cosine 60 times sine 45. This value will be negative 221.4. This one will be 300 times cosine 60 times cosine 45. This value will be 221.4. 300 times sine 60. This one equal 259.8. For F1. For F2. F2, where is F2? Here is F2. We have first angle 60. We have second angle 45. We have third angle is given. Wow. 120. So we have alpha, we have beta, we have gamma. Everything is ready for you. Be careful, these angles must be between the force and the x-axis, between the force and y-axis, between the force and z-axis. So F2 as a vector equal F2 cosine alpha, I, F2 cosine beta, J, F2 cosine gamma, K. How much F2? 500 cosine 60, 500 cosine 45, 500 cosine 120. Your final component for F2 is 500 times cosine 60, 250. I. 500 times cosine 45. Your value will be 353.5. J. I think this one will be negative. 500 times cosine 120 will be negative 250 K. This one is the X component. This one is the Y component. This one is the Z component for F2. But we are not looking for components for each force. We are looking for resultant force. We are looking for resultant force. Okay. To figure out the resultant force, we need to add all of horizontal components together. All of X component together, all of Y component together, all of Z component together. Go ahead. X component here, negative 221.4. X component here equal 250. Get your value. Y component here, positive 221.4. Y component here, 353.5. What is the value? Z component, 259.8. And Z component here, negative 250. You can get your values. Negative 221.4 plus 250. This value equal 28.6. 221.4 plus 353.5. This value equal 574.9. 259.8 minus 250. This value is 9.8. Just to let you know, summation of all horizontal components and Y component and Z components are the components of your resultant. So X component for the resultant force equals this value. Y component of the resultant force equal to this value. Z component equal to this value. if you are looking for final value for the resultant force, will be square root of this component square plus this component square plus this component square. So I can figure out the final value of the resultant force under square root will be 575.7. Here is the resultant value. The resultant force value 575.7. If you are looking for cosine alpha, cosine beta, cosine gamma for this resultant force, okay, x component divide this force, I can get cosine alpha. Y component divide this force, I can get cosine beta. Z component divide this force, I can get the cosine alpha, cosine gamma. This one is gamma. Once you get cosine alpha, cosine beta, cosine gamma, inverse cosine, I can get alpha, beta, gamma for R. Guys, do you remember here? If you have something is given with 3 components, I can get it as one value. And I can get the angle of this value, cosine alpha, cosine beta, cosine gamma. So the situation right now is summation of all x components, summation of all y components, summation of all z components represent the x components, the x component for resultant force, the y component for resultant force, the z component for resultant force. So I can convert this resultant force as a vector to a value. And I can figure out the angles of this value by cosine alpha, cosine beta, cosine gamma. So your final answer, we are looking for what is the magnitude, what is the value of R, which is 575.7, and what are the coordinate direction angles, which is alpha, beta, gamma for this resultant force. We are done with alpha, beta, gamma for this resultant force. Just we need to add the component, the x component for this resultant, divide R. The y component of this resultant, divide R. The z component of this resultant, divide R. I can get cosine alpha, beta, gamma. Inverse cosine, I can get alpha, beta, and gamma. Any question?